Okay, so this is the final example, example number 3 for the grade 11 lesson 1.3, the sine law. So this is an advanced example, so if you feel like you've got a handle on example 1 and example 2, that's why you're working on example number 3. So this question is a little bit more difficult because we're going to be combining the sine law with SOHCAHTOA. So in this question, it gives you this picture that you've got in front of you, and it's asking for you to find H. Okay, so I see multiple triangles in here. I see a right angle triangle, and I also see a non-right angle triangle. So this question is all about visualizing, erasing some lines in your mind and highlighting other ones. So SOHCAHTOA is always very easy to use. So I'm going to take a look at this. If I were to find H here, I know that this is our opposite side, this is our hypotenuse, and this is our adjacent. But if I list out what I have, the only thing I have is 56 degrees. I don't have any other side here. So we need to have a degree and one more side in order for SOHCAHTOA to work. So we automatically know that SOHCAHTOA is just not going to work. So no matter how many times I try, you can try everything. Try, see if you can sub in for sine, cos, or tan. Nothing's going to work. So what I'm going to do is just take a look at this outside triangle here, and I'm almost going to erase this H from your mind. Okay, so I'm just going to erase it for a second, but it still does exist. If I take a look at this triangle here, I've got one side and I've got two angles. So this is perfect for the sine law. And if we use the sine law and we're able to find this side here, then when I put my H back, if I'm able to find this side here, when I go back to do SOHCAHTOA, I'll have one side length and one angle, and I'll be able to use H. So let me sort of erase all the extra drawings I've had here. So here's the plan that we're going to use. We cannot find H right away just using SOHCAHTOA. So we're going to do two steps. One plan is find an outside side length using the sine law. And then the second plan is we are going to, once we have an outside side length, either here or here, then we can use SOHCAHTOA to find H. Use SOHCAHTOA to find H. Alright, we've got a plan. Now let's do the plan. Okay, so the first part of the plan, don't forget, is we're going to treat this as if this H wasn't in here. So we're just looking at this outside triangle just like this. So just looking at that outside triangle, almost imagining that H line isn't there. Let's label this triangle using A, B, C, D so that we can plug it in for sine law. So I'm going to pick whatever I want. Let's pick, let's make this big A, this big B, this big C, which makes this, of course, little a. And then we've got across here, this whole thing must be little b, and this whole thing here must be little c. So now let's plug in. Let's write out the sine law. So we've got little a over sine of big A equals b over sine of big B equals c over sine of big C. So we're going to plug in what we know. So let's just start with little a first. Little a we do not have, so we're just going to leave it as little a. So we have little a all over sine. Do we have big A? Yes, we do. It's 43 degrees. And little b, do we have it? Yes, we do. It's 68 degrees. All over sine of big B. Do we have big B? No, but can we figure it out? Yes, because we've got two angles, and we know the trick. The trick is that all the angles inside of a triangle have to equal 180. So we have angle B is going to equal to 180 minus 43 and minus 56. What that means is angle B is going to equal 81 degrees. So I'm going to go put that in. This whole thing is to be 81 degrees. Okay, so let's keep on adding in there. So we've got angle B was 81 degrees equals little c. Do we have little c? Take a look. We do not, so I'm going to leave it as little c. And over sine of big C, we've got that, it's 56. So I'm going to put in 56. Okay, so we know the deal with sine law. We're going to pick one fraction that's complete. Let's take a look. We've got a complete fraction here. The other fraction has to include the thing we're looking for. So back to our plan, we just need to find an outside side length here. So we could pick C or we could pick A. It does not matter. So let's just together we'll pick A. So we're looking for A here. So then the other one we're going to highlight then is this fraction here. So we're going to keep on going just like we've been doing in the first two examples. So we're going to rewrite these together. So we've got A over sine of 43 equals 68 over sine of 81. Okay, let's remember that we're looking for A here. So we are going to remove, we want A to be by itself. So that means that we need to take away this sine 43, and this is a little divided by symbol, don't forget. So this is divided by sine 43. So when we bring it onto the other side, it's going to turn into times sine 43. So let's do that. So we're going to rewrite this as A equals, because we're taking the sine 43 and moving it away, 68 over sine of 81, and then we're going to multiply that all by sine 43. So when you put that into the calculator, you're going to put 68 divided by sine 81 times sine 43. You're going to get 46.95. Okay, so if you didn't get that, just triple check your calculation. And now what we're going to do is we're going to put that label back up to our triangle. So 46.95 is our A. So I'm going to write here 46.95. Okay, so now let's take a look back up here. The whole goal of this is to find H. So now to find H, we need to use this right angle triangle. So I'm going to highlight this for you so that this is all that you're looking at now. We don't need the other triangle. So all that we need to be able to use SOHCAHTOA here to find H is we need an angle, check, and we need a side length, check. So now we're good to go. So now we're going to label this triangle as if we're using SOHCAHTOA. So I'm going to, just to make it super clear, I'm going to erase some of these other things that we've got going on here to make it like everything really, really visible to us. Okay, there we go. So we are going to label this as we normally do. So this one is definitely going to be the hypotenuse. And then we've got, here's our angle, so we're going to go across, and that's going to give us the opposite. So we've got opposite here, and then we've got adjacent here. So if we do our list, we're going to write our list that we have the hypotenuse, we have the angle, and we need opposite. So that's what we're going to write underneath. We can go back and forth. So we are on to step 2, by the way. Step 1, we found a side length of the outside. Now we're going to use SOHCAHTOA to find H. So we're on to step 2. If you want to write step 2, go for it. Step 2, so we're using SOHCAHTOA. Alright, so we have already labeled, so now we're just going to list what we have. So if you check back up there, we have the hypotenuse. We have the angle, 56 degrees, and we need the opposite side, which was H. Okay, so if we did this right, we know we should have 3 pieces of information here. 2 of them should be side lengths. We've got hypotenuse and opposite. Which of these, sine, cos, or tan, will use hypotenuse and opposite? We know that that has to be sine, so therefore use sine. So we're going to write out our equation. So we know that sine of an angle equals opposite over hypotenuse. So I'm going to write it out. Opposite over hypotenuse. So we've got sine of an angle. Our angle is, let's take a look here, it's 56 degrees. So we're going to use that. sine of our angle 56 degrees equals opposite, which if you check back is h, over hypotenuse, which we found 46.95. So we're on our last step here. We want to get h by itself. What's in the way of h being by itself? Well, it's this divided by 46.95. So we're going to bring it onto the other side, and it's going to turn into 46.95 times sine of 56 is going to equal h. And if we plug that all into our calculator, we get 46.95 times sine of 56. It's going to equal 38.92 meters. And there is our final answer. Phew! That was a long one. So if you could take back a look at our original thing here. Okay, so just as a reminder, whenever you have a triangle like this, where we've got multiple triangles here, I see a right angle triangle here in yellow, but then I also have a non-right angle triangle here. We might need to use a combination of the sine law and SOHCAHTOA to be able to find what we're looking for. So in this case we're looking for h. We always want to try to use SOHCAHTOA if we can because it's so much easier. But in this case we didn't have a side length, so we need to find a side length, and that's why we use sine law, and we use it for this giant triangle here. So if you think you've mastered it, that's fantastic. If you think that you need a refresh, go through any step in this video that you didn't get through, and you are ready to go on to the practice activities on the next part of the lesson.